Here is the customized list. We called it list class. As we mentioned, that is going to have a list as an array of type string and number of items, which is an integer that represents the number of elements we are going to use in the array. So the class will be basically a wrapped class because we are putting the array inside, and the array processing or entering the array or adding elements to the array is controlled by the class itself. So what does it mean an array is wrapped in a class? It means we define a class that has an array inside it, and we make this class takes full control of the array processing. So if we want to add elements to the array, then the class should be responsible for that. So controlling these data members, the list and the number of items in the class should not be exposed outside the class because it should be fully controlled by the class. And to do that, we define them private data members. So the list, which is an array of type string, and the number of items, which is an integer, we are going to define them as a private data member. And we are not going to provide any setters and getters for these data members. Why? Because we want the class to take control of these data members, not any user of the class, which is an object that can change their values. Therefore, we can say that the array and the associated variable that represents the actual size of the array are managed only by the wrapped class. To make the class take full control of the array, the class must provide public methods that are used by the objects created from this class to process the array elements. For example, if you want to add an element to the list, then a method should do this job for you. So therefore, we need to know what are the public methods that we need for this class so that the objects created from this class can manipulate the array inside the class. Let us have a look into these methods. The public methods that we are going to define for this class, first we have two constructors. The first one is a default constructor that will create a list as an array of size 10. So the size of the list will be exactly 10 strings and will initialize the variable number of items to 0. The second constructor, it will have a parameter that specifies the size of the list, which is the maximum size. As if you remember, we called it the capacity, which is going to be the length of the list. So it depends on what is the size you want this list to have. You provide as a parameter to the constructor this size, and the object or the class will create the array of this size. So it is to create a list as an array of size, maximum size, and also will initialize number of items to 0. In addition to the two constructors, there are two methods. One is responsible to test whether the list is full or not, and the other one is responsible to test whether the list is empty or not. The first method, the name is full, that returns true if the list is full. Otherwise, it returns false. Therefore, the return value for this method is a Boolean variable. The second method is empty, that returns true if the list is empty. Otherwise, it returns false, that the list is not empty. Therefore, the return value for this method is Boolean. If we want to talk in terms of implementation, how to check that the list is full or not, we test number of items with the capacity. And how to check if the list is empty or not, also we test the number of items. If it is equal to 0, so it is empty. In this wrapped class, one property is added is that whenever the user tries to add an element that is already in the list, should reject it. In other words, it should not allow to have duplicate elements in the array. And to do that, the class uses the public method isOnList. This method takes as a parameter a string y and returns true if the string is on the list. So basically, this is a searching problem. So it will search for y in the list. If it is there, then it will return true. And if it is not there, it will return false. So here we are testing for containment, if the element is in fact on the list or it is not on the list. Now we come to the method that is responsible for adding items to the list. The method is called addItem, that will take as a parameter a string and will add this string to the end of the list. But before adding the element to the end of the list, it should make sure that it is not full. There is a space that we can add this element, and at the same time it does not exist in the list. To do that, we can check for the method whether it is full or not by using the method isFull, and to check that if the element is on the list or not by using the method isOnTheList. Finally, if we want to get an item at a certain index in the list, we use the method getItemAt that retains the item at a position specified as a parameter. So this will give us the item at a certain index inside the list. Before we write the implementation of the class, we would like to write a test program that shows you how to use this class to create a list of items and add them on the list. At the same time, to show you how to use its methods for processing the list. For testing the list class, we are going to write a Java program to do the following. First, create an object of list class called ToDoList that will be used for keeping list of items such as a grocery list or a list of things to do for maximum 10 items. Let us go to JGrasp and implement this part. To create an object of list class, we write list class, and the name of the object will be ToDoList, as the question suggests. And here we are going to create an object from this class. So we say new list class, and now which constructor we should call. Remember that the class has two constructors, one that initializes the list for exactly 10 items or 10 elements, and the other one is that you supply the size. We can use either of them. So we will leave it for the default constructor, or you can use the other constructor by supplying 10. In the second part, we want continuously ask the user to enter items of ToDoList and add them to the object created in part A called ToDoList. Stop reading when the user enters the word end. Let us go to JGrasp and do this part. To continuously ask the user to enter items or activities of ToDoList and stops reading when the word end is typed, we implement a sentinel-controlled while loop. So let us ask the user first to give us the activity or item by saying, what do you want to do? And we are going to read it in a string. We are going to call it activity. Now, since we are going to read a text, not single word, then we are going to use the next line instead of next, because we assume that the user will type more than one word. Now, to check for the sentinel end, we write the while loop, and here we are going to check for the sentinel, and if it is not equal to the sentinel, we will enter the loop. Let us write the condition that checks that the input is equal to end. So we write activity, and we are going to use the method equals ignore case, because this is a string and we cannot use the equal operator. So we will say equals ignore case, and we will check for the word end as an input parameter. Now, since we want to continue if the user did not type end, so therefore we have to put the negation of the condition, and we put exclamation mark in front of calling the method equals ignore case. After reading the activity and it was not equal to end, we need to add it to the list. To add it to the list, we write ToDoList, which is the name of the object, followed by the method that is responsible for adding elements to the list. And this method, as we discussed before, we defined it as add item, and we will provide the activity as an input parameter that should be added to the list. After adding the activity, we need to check for the next activity. This is a sentinel-controlled while loop. So we will copy these two lines and we paste them inside the loop for reading the next activity. So now if the next activity is equal to end, it will exit the loop. Otherwise, it will keep adding the activities to the list. But for how long we keep adding activities to the list? Remember that the list has a capacity. When we created the list, we called the default constructor, and it was created for only 10 items. So therefore, we should not allow the user to enter any number of activities without testing that there is enough space in the list. Therefore, in addition of testing that the entered activity is equal to end, we need to check that the list is also not full. And to do that, we have to call the method isFull to tell us whether the list is full or not by typing and not full. So we write not and then the name of the object to do list, which is the object of the list, and then we call the method isFull to tell us whether the list is full or not. This completes the implementation of this part, and notice that the while loop will stop if the activity name is equal to end or if the list is full. So let us test now the program, but to test the program we have to write the definition for list class. So far, how many methods we have used from this class? We have a constructor, the default constructor, we have the method isFull, and we have the method addItem. Let us just implement the class up to these methods, and then we will show you later how to add the implementation of the other methods. So here is our class definition. First, we need to define the data members. One is list as an array of a string. So private string as an array, and we are going to call the array inside the class list. Also, we need to define a private number of items of the list as integer. So int number of items as an integer. Now we go to the default constructor. The default constructor will create a list of size 10 and will initialize num of items to 0. So we write public, and the name of the constructor is list class, and it does not have any input parameter because this is the default constructor. So we will say list equal to new array of a string of size 10. And also we will initialize number of items to 0, assume that we don't have any element in the list. Now for the constructor that we specify the size of the list, it will be public list class, the name of the class, followed by the input parameter, which is the maximum size as an integer. And we will do exactly the same what we have done for the default constructor, except that the size will be as the input parameter. So we will copy the code from the default constructor, and in place of 10, we will write maximum size. I will define maximum small letter m, and here we are missing a bracket. Now for the method isFull. To test that the list is full or not, it should return a Boolean value, public Boolean, the name is full without any input parameter, and it should return the result of the following expression, return, and we are going to test that if the length is equal to number of items, then it is full. So we say number of items equal list dot length. Now for empty, we will just simply check for number of items is equal to 0. So we will copy the code for isFull and we will paste it, and we will call the method isEmpty. And here we will check for number of items is equal to 0. So if number of items is equal to 0, then this expression will return true, otherwise it will return false. To implement addItem method, we have to make sure that the item we want to add does not exist on the list. To do that, we use another method which is called isOnList. This method takes a parameter as a string y and returns it true if y is on the list. So the definition for the method is public Boolean isOnList, and it will take a string called y as an input parameter. Now we have to check every element on the list. If it is equal to y, then the method returns it true. Otherwise, if none of the elements on the list is equal to y, the method will return false. So we write a for loop for integer I equal to 0, I less than. Now for the length, we should not use length of list because length is the capacity of the array. We have to use number of items, which is the actual number of elements used of the array. So here we write num items I plus a plus, and in each iteration we have to check for the value of list I with the value of y. And since we are comparing strings, so we are going to use the method equals ignore case and supply y as an input parameter. If any of the elements on the list is equal to y, then the method will return true. And if all elements, none of them is equal to y, then the method will return false. So let us implement the add item method. It is going to be public and it's going to be void because we are going to add an item and there is nothing to return, and the name of the method is add item. It will have one input parameter, which is the item that we need to add on the list, and it is called y. Before we add y on the list, we have to make sure that the list is not full at the same time that the element that we are going to add is not on the list. So we write an if statement, we say if, and we are going to call the method is full to test that the list is full or not. And if it is full, then we display a message by saying that cannot insert a new item. The reason is that list is full. Else, we check that the element is on the list. So we say is on list between a bracket y. If this method returns true, that means the item is on the list. So we display a message by saying that cannot insert a new item, and the reason is that already exists on the list. Finally, if the list is not full and if the item we want to add is not on the list, now we add it on the list. To add it on the list, we write list num of items is equal to y, and we increment number of items by 1 to indicate that we have added one element in the array. And this will complete the implementation of add item. So let us compile the class and check that it does not have any errors. We save it. We check by clicking compile. So there is an error. Num items, it seems that we did not define it. Oh yes, here I'm missing s. It should be num items. Let us compile again. And now it is free of errors. So the class now don't have any errors. Let's go to the list demo, which is our program, and compile it and see if it has any errors or not. Again, we save it. We click compile. So there is an error. The problem here is that we are redefining activity. In this case, I have to remove the declaration because I have already declared it before in previous lines. Let us now compile it again. Now it does not have any errors. Now it's time to run the program. So let us run the program and add some to-do list. Here it's asking what do you want to do. Let's say, for example, eat breakfast. Another to-do list is take a walk for 1 hour. Let's say another to-do list is, for example, withdraw money from the ATM. And let's say at the end, we want to end and the program terminates. Let us try it for some to-do list such that the list will be full. So I'm going to create a list with, let's say, 3 items only. Let's run the program again. So it's asking now for activities, to-do list. Let's say eat a breakfast, take a walk for 1 hour. Let's say now withdraw money from the ATM. Now the list is supposed to be full. Let's say pay the bills. And now see the program has stopped because the list became full, but no message was printed on the screen. As you have seen, when the list became full, no message was printed on the screen. So what is required now in part C? It says when the last item is added in the list, print the message list is now full. So that means when the last element is added on the list, we need a message to be printed on the screen before exiting the loop. Let us see how we can implement this in our program. Where and when do we exactly check whether the list has become full or not? We check that the list has become full or not whenever we add an activity or an item of to-do list. And where is that? It is in fact here after we add an activity. Here we will test the list and we will say to-do list is full. And if it is full, then we display a message system.out.println saying that list is now full. But if the list is full, then there is no need to read for the next activity. In fact, we should stop. So therefore, we have to put here else statement. And if it is not full, then we are going to ask for next activity. Otherwise, we should skip it and go back to the beginning of the loop. And since the list is full, then it will exit the loop. We will format the lines by clicking this icon and then clicking the icon next to it to come back. And now the program is formatted. So let us run the program and test for some input. So what do you want to do? Let's say, for example, eat breakfast, then take a walk for an hour, and then withdraw money from the ATM. And then now it says that list is now full and we have exited the loop. It seems that we have put extra backslash, so we deleted to remove it from the output screen. And this completes the implementation of part C. In the last part, after all the items are added to the list, we need to display them on the screen. Now we need to think about how to display the elements inside the list, inside the array of the class. Remember that the list, which is the array, defined inside list class as a private data member. So there is no way we can access it from outside the object. Therefore, we need to look into the class definition again and see what method can help us to give us the elements inside the array. Let us go back to the list class definition. This is the class definition for list class. And remember that the list as an array was defined as a private array inside the class. Therefore, we cannot access its element from outside the object. But notice that we have implemented all the methods except the last method, that its purpose is to get the item at any position specified as a parameter. So therefore, we are going to use this public method to give us the items one by one. Let us first implement this method, and then we will use it to print all the elements inside the list. So the definition for getItemAt is that it is a public method. It's going to return a string because the items on the list are strings, and the name will be getItemAt, and the input parameter for this method is a position, which is an index of the elements that we want this method to return as an item. So now we have to check that the position is within bounds. If it is not within bounds, then we have to return a null string, indicating that the element does not exist at that position. So here we say if position greater than or equal to 0 and position is less than number of items. Notice here we are not using equal here because we are talking about indices. And indices of arrays starts from 0 until number of items minus 1. If this is the case, then this method will return the string at position POS. Now, if position is out of bound, then the method will return a null string. And we write here, return null. Therefore, if the input parameter position is within range, then the method will return the item at that position. Otherwise, it's going to return none. Let us see how we can use this method to get the items of the list one by one and print them on the screen. So let us go back to our program. After we entered all the activities and saved them on the list, now we want to print them on the screen. To print them on the screen, then we have to get them the items one by one using the method getItemAtPosition. So we will have a local variable that's called POS, that stands for position, and we will start taking the elements at position 0, then next element, until we find that no string is found on the list. We will use getItem method to get the items. So we will use the activity string that we have defined on line 13. So we are going to use it again, and we will say activity is equal to do list dot get item at, and we will use POS as input parameter. So first it will give us the first item at position 0 and save it into activity. We need to check the activity. If it is null, then we should stop. So we will write a while loop and we will say while activity is not equal null, then we will print the activity and read the next item on the list. So here we will say system.out.println, and we are going to print the activity which was saved into activity. And for the next iteration, then we have to read the next item, but before we read the next item, we have to update position and make it go to the next position. And then we call the method getItemAtPosition for the new position for the next item. So in this loop, basically we are using POS variable as an index to get the item on the list at this index using the method getItemAt. And whenever the getItemAt method returns null, that means that the position is beyond the list capacity, and therefore we should stop. So now is the time to run the program. We have to go to the class definition and make sure that it does not have any errors. We save it, we compile it again. So there is an error. Yes, we forgot to put semicolon. Save it again and compile it. Now it does not have any errors. We return back to our program and run it for testing. So now it is asking for to-do list, and we will say that first eat breakfast, and then we will say take a walk for an hour, and then we will say withdraw money from the ATM. And now as you see, it says that the list is now full and it has printed all the activities on the list one by one.